During sunrise or till noon, the shadow is seen on the western side. At noon, the sun is overhead and hence the shadow is almost at your feet, and then it slowly moves towards the east during sunset. This happens due to the rotation of the earth around its own axis. This is the sun's east-west apparent movement, which is the diurnal movement of the sun. Diurnal apparent motion is the sun's east-west motion from sunrise to sunset. Children, we will now talk about something similar which takes place throughout the year and is responsible for what we call the seasons. Here we will consider the movement of the sun from north to south. But aren't we aware that the sun never moves? It is the earth that revolves around the sun. So what do we mean when we say the movement of the sun from north to south and back to the north and so on, which is called as the apparent movement of the sun? Let us try and understand this concept of the apparent movement of the sun with the help of an activity. Take an orange, which acts as the earth, and pass a stick through its vertical section. We will consider this as the axis of the earth. With a marker, draw the equator, the Tropic of Cancer and Tropic of Capricorn on the orange. Next, take a pointed source of light mounted on a socket and which acts as the sun. With the source of the light as the sun, rotate the orange on its own axis and at the same time revolve it around the sun in its elliptical path and in one plane. Remember to keep its axis tilted. Dear children, observe the path of the perpendicular rays of the sun. Which part of the earth do they fall on? What do you observe? The rays of the sun are perpendicular only between 23.5 degree north and 23.5 degrees south latitudes, that is, between the Tropic of Cancer and Tropic of Capricorn, or in other words, only the area between 23.5 degree north and 23.5 degrees south latitudes receive perpendicular rays during different times of the year. When the rays of the sun fall perpendicular on the equator, during the revolution of the earth, we have equal hours of day and night. This happens twice in a year. Once during the spring equinox in the month of March, 21st or 22nd March, and once during the autumn equinox in the month of September, 21st or 22nd September. As the earth continues its revolution, due to this tilt of 23.5 degree, the sun's rays fall perpendicular on the Tropic of Cancer, that is 23.5 degree north latitude in the month of June, 22nd or 23rd. This is the day when we have the longest day in the northern hemisphere and shortest day in the southern hemisphere. More area of the northern hemisphere receives the rays of the sun. Thus, it is the summer season in the northern hemisphere. As the earth moves further in its revolution, again due to this tilt of 23.5 degrees, the sun's rays fall perpendicular on the Tropic of Capricorn, that is 23.5 degrees south latitude in the month of December, 21st or 22nd. This is the day when we have the longest day in the southern hemisphere and shortest day in the northern hemisphere. More area of the southern hemisphere receives the rays of the sun. Thus, it is the summer season in the southern hemisphere and winter in the northern. Summary. Dear children, Figure 6 shows the position of the sun that is seen by an observer during the entire year. The sun appears at 73.5 degree on June 21st, which is termed as summer solstice. It then shifts to 50 degree during the autumnal equinox on September 21st. It continues its journey and moves towards 26.5 degrees on 21st December, which is termed as winter solstice. The sun is then seen traveling back to 50 degrees during the spring equinox, that is 21st March. This journey of the sun from the north to the south, 73.5 degrees to 50 degrees to 26.5 degrees, and back to the north again 50 degrees to 73.5 degrees, is what we know as Uttarayan or Dakshinayan. This is the apparent movement of the sun. Remember, the sun is never moving. It is the earth that is revolving around the sun with an inclination of 23.5 degrees. Exercise. Dear children, have you observed your own shadow during the day? Try and observe in which direction you see the shadow from sunrise till noon. Then, what is the state of the shadow at noon? Also, observe the shadow after noon till sunset. Have you noted your observation?